do is, and I'll just disconnect this from the output, is try and find out if there is any correlation between various fields. So these are my operators. This is my operator window and it has got various operators. Let's try and find out a correlation matrix and drag it here and just say, after retrieving the data, I want to create a correlation matrix and the example, and I want to see the matrix itself. Just go and hit play. Here it shows us the correlation matrix for all the attributes we've got against themselves. So we can say that safely that the volume per week has got a very strong correlation with trading hours, and not that strong, but strong correlation with ATMs in the trading area. It doesn't matter which market it is in and what site type it is. It's actually negative. They're very weak negative correlation, and whether it is on the main road or not has got a weak correlation itself. So it's quite good. And you can also look at a pairwise table, so you can see the whole all kind of combinations you can have, and you can plot them as well as it comes standard. So the first attribute against the second attribute, and you can see the scatter plot in itself. The example set comes back as it is, and this is our data view. This is our data which we started with. Now, the next thing we're going to do is, as we've seen that there is the correlation matrix, the next thing we're going to do is build a little model for our problem and try and see if we can find out relationship or a regression equation which can be used in the future to predict the volume per week for the stores they've got, for the new stores they're coming in their plan. So let's go, and at this time first save our process and then go and insert. So at this point in time, let us go and insert a cross-validation so that we can we can throw a regression model and then cross-validate the performance for the model. So I'll go to the operators and look for cross-validation, which I've got here, and I'll just drag it onto the main process area. Now I've got my example set which I got from the correlation matrix. I'll just key that into the validation area. Now validation the cross-validation in itself is a nested process, so I'll double click it to find out, and it's got two areas, the training area and the testing area. So let's go and put in SVM support vector machine model on here and drag it into the center. Now let's connect the transactions. Oh, by the way, RapidMiner is fairly intuitive. If it sees an error, it can actually fix it by itself. So if you right click on mod, it will say for a quick fix, it needs to connect to the SVM model. So it is intelligent enough and it connects to the SVM model. You can do it this way. The next thing you want to do is apply the model, and I'll drop this here. Yet again, I can right click and say give me a quick fix, and then I need to check the performance of this model. So I'll go and look for performance. And I'll just drag it here. Again, I can create a quick fix. Sorry, wrong, disconnect ports. I just want to connect these two, and then I want the output as performance and the example set. I also want to get the threshold weights, and this can be part of my threshold in here. Now there is some problem I can see here. I can just see it wants to convert all the attributes to numerical. I'll just let it do that. Here we go. So it's converted all of them. Now, what we've missed here is that for any of the prediction model, we need to actually define the target variable, which we've forgotten altogether. So let's go and set and I would want to connect but I need to define the role, and so we had to define volume per week is what we're looking for and call it a label. As an end result, we want the model and we want the performance for it. Let's try and look what's going on here. It's all good, hasn't got a problem. And let's try and run it if we don't find any issues. Okay, it's got some problems. Let's look at doing some quick fixes. And it says, let's have a look. So we've got most of our stuff. Let's get back and play. And that's a model generated. So let's look at the performance. So the performance root mean squared error has been calculated here for this model, which is 59,054, and the standard root mean square. So it's a pretty robust model if I look at. And this is our correlation matrix which we were looking for, and this is the SVM model. So the SVM model is a linear model where it has got the intercept to be 163,430 with the weight for the site type to be -18, market to be -4, ATM to be 18, so the main price board to be 12, and so all we need to do is multiply this with the attributes and add 163,430 to get our predicted value. We can see the weighted value here, and that's absolutely the same as in the text view. So that's how we've done the correlation, we've actually reviewed the data, and we've also built a model to predict the volume the business is going to sell in opening up a new store at a place based on the various variables they've got. It's a very easy to use tool, RapidMiner. Go download it at www.rapidminer.com and play with it and help you turn data into money. Thank you for watching this tutorial. Please log into my blog advanced-analytics.blogspot.com and leave your comments. Thank you.